Potentiometers and rheostats create a change in their resistive value when a connected shaft is physically rotated. Resistors provide a fixed value of resistance that blocks or resists the flow of electrical current around a circuit, as well as producing a voltage drop in accordance with Ohm's law. The potentiometer, commonly referred to as a pot, is a three-terminal mechanically operated rotary analog device which can be found and used in a large variety of electrical and electronic circuits. They are passive devices, meaning they do not require a power supply or additional circuitry in order to perform their basic linear or rotary position function. Variable potentiometers are available in a variety of different mechanical variations, allowing for easy adjustment to control a voltage, current, or the biasing and gain control of a circuit to obtain a zero condition. The name potentiometer is a combination of the words potential difference and metering, which came from the early days of electronics development. It was thought then that adjusting large wire-wound resistive coils metered or measured out a set amount of potential difference, making it a type of voltage metering device. There are many different types and names ranging from variable resistor, preset, trimmer, rheostat, and of course variable potentiometer. But whatever their name, these devices all function in exactly the same way in that their output resistance value can be changed or varied by the movement of a mechanical contact or wiper given by some external action. Rotary potentiometer, the most common type, vary their resistive value as a result of an angular movement. Rotating a knob or dial attached to the shaft causes the internal wiper to sweep around a curved resistive element. The most common use of a rotary potentiometer is the volume control pot. Rotary potentiometers can produce a linear or logarithmic output with tolerances of typically 10 to 20%. As they are mechanically controlled, they can be used to measure the rotation of a shaft, but a single-turn rotary potentiometer normally offers less than 300 degrees of angular movement from minimum to maximum resistance. Slider potentiometers, or slide pots, are designed to change the value of their contact resistance by means of a linear motion, and as such there is a linear relationship between the position of the slider contact and the output resistance. Slide potentiometers are mainly used in a large range of professional audio equipment such as studio mixers, faders, graphic equalizers, and audio tone control consoles, allowing the users to see from the position of the plastic square knob or finger grip the actual setting of the slide. One of the main disadvantages of a slider potentiometer is that they have a long open slot to allow the wiper lug to move freely up and down along the full length of the resistive track. This open slot makes the resistive track inside susceptible to contamination from dust and dirt, or by sweat and grease from the user's hands. Slotted felt covers and screens can be used to minimize the effects of resistive track contamination. Preset or trimmer potentiometers are small, set-and-forget type potentiometers that allow for very fine or occasional adjustments to be easily made to a circuit. Single-turn rotary preset potentiometers are miniature versions of the standard variable resistor designed to be mounting directly on a printed circuit board and are adjusted by means of a small bladed screwdriver or similar plastic tool. Trimmer potentiometers, or trim pots, are multi-turn rectangular devices with linear tracks that are designed to be installed and soldered directly onto a circuit board either through-hole or as surface mount. This gives the trimmer both electrical connections and mechanical mounting, and encasing the track within a plastic housing avoids the problems of dust and dirt during use associated with skeleton presets. Rheostats are the big boys of the potentiometer world. They are two-connection variable resistors configured to provide any resistive value within their ohmic range to control the flow of current through them. While in theory, any variable potentiometer can be configured to operate as a rheostat, generally rheostats are large high-wattage, wire-wound variable resistors used in high-current applications as the main advantage of the rheostat is their higher power rating.